Hello everyone, welcome back to our channel. Today we are back with one more matrix related problem that is there in Blind 75 SD sheet. So the name of the problem is spiral matrix. Let's see the problem statement. The problem statement is quite straightforward. So let's see. We have been given an M cross N matrix. We have to return all the elements of our matrix in spiral order. Okay. So I have taken an example to explain you all in a better manner. So suppose we have the matrix of order m cross n. Basically m is like basically row and m and n are basically the size of rows and column. Basically this is a horizontal thing is row and vertical lines are columns, right? So we have been given in this matrix, this is a matrix of 4 by 3, 4 by 4, okay, square matrix basically. So what we have to do is basically you can see we have to print the content of this matrix in a spiral manner. Okay, how we will be doing so, let's see by the arrows here. So what we have to do, we have been provided with this input matrix. So after evaluating this, we have to print it in this form, like we have to print it like this: 1 2 3 4 8 12 16, then 15 14 13, then 9 5 6 7 8, then 12 11 10. Okay, like this. So we can see the round basically in square matrix. This is happening. What is happening? Why we are saying spiral? Because it is making a shape of a spiral, right? See, you can here. This is the shape of spiral. Okay. So these are the constraint given, like m equal to matrix dot length and n is equals to matrix I dot length. M should be greater than equal to 1 and n should be less than equal to 10, and matrix of like number of cells should be greater than equal to minus 100 and less than equal to 100. Okay. So basically what we can do in this problem, like we have to, in this approach we have definitely we will be using for loops, which is essential thing for solving this matrix problems. So what we will be doing is basically we will be using 4 for loops to print all 4 sides of the matrix. Like first of all this horizontal row, then vertical column, then again horizontal row, again vertical column, then again horizontal, and again vertical, and again horizontal, like this. Okay. So how we will be doing this is like basically first of all, first loop will we will be using 4 loops. Okay, first loop will print this, like this horizontal row. Then second loop will print this, the like vertical column. Then third loop will print this horizontal row, and again fourth loop will be printing this like vertical from bottom to top. Okay, so let's see. Suppose we have elements like basically this in this approach we will be initializing the 4 variables also. I will tell you what those variables are. Do not need to worry. Like creating and initializing variables top as a starting row index. You can see top is basically the starting row index. Row is basically the horizontal one. Okay. So start initializing the variables top as row index, starting row index, and bottom as ending row index. So if we start from here, so the ending row index will be like we will traversing from here, then from second, then third, and at last this will be the bottom row index. Okay. So we are initiating the variable with here with the bottom, and here it is the top. Okay. And again we have to the way we initiated the rows, we also need to initiate the columns also. Like we will take left and right. Starting column index will be left, like this particular thing, this particular vertical thing is left initializing to left variable, and this particular thing is initializing to right variable. So now we just need to iterate. So I will be telling you step by step, like in each outer loop traversal print the elements of a square in a clockwise manner. Clockwise means like this, clockwise. Okay. After that we have to print the top row. For printing the top row, please be careful. Like for printing the what I'm going to say is very key concept of for solving this problem. Basically, for printing the rows, we need the use of columns. Okay, and for printing the columns, we need the use of rows. How? I am going to tell you this. So suppose we have to print this 1 2 3 4. So what we will be needing is basically the column. Okay, like how we will traverse, we will be using for int I is equals to left, because this is starting and we have to end it till here, like 1 to 4. It is the starting value and this is ending. So we have to traverse like this horizontally. Okay, so we will be giving the inside the for loop, we will be traversing from I is equals to left and I until that I is less than equal to right. Similarly, you all can see we have to print the elements of top row from column index left to right and increase the count of the top. So why we are increasing the count of the top? So after increasing the count of the top, it will go to the next row. Okay, printing so top, so that it will move to the next row. Similarly, okay. So suppose we have printed this. We have printed this. Let me take the laser pointer. We have printed this point, this particular row. Now our top will be pointing here. Okay, so and after that we have to print the this, basically the vertical right column. We can say we have to print the right column. So as previously as I discussed, it was we have printed the row, so we were requiring the column to in order to print the rows, but this time we have a column, so we will be making the use of rows, like horizontal rows. So how we can make the use of horizontal rows? Like we have to traverse it, like while for I int I is equals to top and I is less than equal to bottom, right? Similarly, you can see, like we have to print the right column, that is the rightmost column for row index top to bottom, and we have to decrease the count of right. Why we are decreasing the count of right? So the next time the right should point here. Okay, okay. So how we will be doing this? Like if top like printing the rightmost column, printing the we have, suppose by using the for loop we have printed this also. Now it's time to print the from right to left like horizontal row. Okay, so for printing the horizontal row, we will be making the use of column as we did in here. But here one condition will come, like we have to print the left column, that is we have to print the bottom row, that is if top is less than equal to bottom, then print the elements of bottom row from column right to left this time. Okay, and decrease the count of bottom. Why we are decreasing the count? So next time it will point bottom should point here. Okay, so similarly after printing the bottom row, we will be going towards the left column, yeah, and we will be checking condition also. If left is less than equal to right, basically we have to check right. If suppose if we have an edge case, right, basically for one like suppose the matrix is of 1 cross 1. So for checking these edge cases, we are putting this condition like left is less than equal to right and top is less than equal to bottom. Okay, so then after suppose we are printing this by the similar approach, and after that we have to run a loop until all the square of loops are printed. So you all can see why as we can see in the code also, a code I will show you. I have done in the online compiler, I will show you, but you can check, like you can raise a question like why we put these two conditions on the last two loops. Okay, so the answer for this is basically, you can see I have written the two edge conditions are being added in the last two for loops when we are moving from right to left and from bottom to top. These conditions are added to check if the matrix is a single column or a single row, as I told you. Okay, so whenever the elements in a single row are traversed, they cannot be traversed again backward. So the condition is checked in the right to left loop. Okay, so when a single column is present, the condition is checked in the bottom to top loop, as elements from bottom to top cannot be traversed again. Okay, so this was all the approach. I will explain you more deeply in the code also. So let's go to code. So this was the function vector int print a spiral. This is the basically 2D matrix, and NNM we have declared for row and column, and we are also initializing our result vectors for storing our result. These are the four variables that we use, that is top is equals to 0, bottom will be definitely n minus 1. Okay, and left is equals to 0, right is equals to m minus 1. Basically top and bottom are rows, like starting index of row and ending index of row, and left and right are starting and ending index of column respectively, right? Then we are having a global while loop, like under this everything will happen. This is the condition while top is less than equal to bottom and then left is less than equal to right. As soon as this situation comes, we have to break the loop. Okay. Now for checking, for printing the top row, like we have traversed from left to right. You can all can imagine it, like for int I is equals to left, that I told you, and we have to push back into the result array, result vector. Similarly, and we have to increment the top also, so that next time it would go to the next top. Okay, we have to move the top boundary to down. Okay, after that we have to take the like vertical column, that is rightmost column. So for printing the column we have to make use of rows. So top and bottom are rows, so we have to iterate over it and we have to print like this, and we have to decrement right. Okay, so that we can move the right boundary to left. Okay, after that we have to print the bottommost row, that is we have to traverse from right to left if still in bounds. Okay, and we have to also tackle here the edge cases. If top is less than equal to bottom, then we have to use this. Basically the concept is same. While printing column we have to make use of rows, and if we are printing rows we have to make the use of columns. So after that we have to decrement the bottom. So in order to move the bottom boundary up, after that we have to traverse from bottom to top if still in bounds. There is a edge case if left is less than equal to right, basically checking the if the row, if particular matrix is one by one, basically single column and single row. So for checking this we are again taking this for loop for pushing back the values. After that we have to increment the left boundary, that is move left boundary right. Okay, after that we have to return the result. Okay, so if we want to like write the main function also, I have done it. Basically with the help of this we have to initiate this matrix. I have basically hard coded the example. Again we have to like call the function, and it's simple, we are returning, and in answer we are getting the output of spiral matrix. Okay, so this was all the approach and code. So I will tell you the time complexity for this approach is basically, you all can see we are iterating row and column wise. So O of m cross n will be the O of m cross n will be the time complexity, where m and n are the number of rows and columns of the given matrix respectively. And since we are dealing with the square matrix, then the time complexity will be O of n square. And auxiliary space is O of 1 only, as we are not using any extra space. Okay, so I hope I was able to clear your clear the approach of spiral matrix. If you guys understood the solution, please hit the like button and also subscribe to the channel, and share it with other students as well. Thank you.